All right, let's talk about software. It's that invisible, almost magical force that powers pretty much our entire digital world. It's the ghost in the machine, the thing that turns a totally lifeless box of metal into a portal we use for work, for play, for connection, everything. So how does it actually work? Well, that's exactly what we're going to break down.
I mean, really think about that for a second. You've got this physical thing, a computer. It's just a collection of circuits and wires and silicon. But then you've got this vibrant, interactive world of apps and games and websites. How in the world do we get from one to the other? What's the bridge that connects the physical stuff to the digital experience?
The easiest way to wrap your head around this is with a simple analogy. The hardware, that's the body. It's all the physical parts you can actually touch, the screen, the keyboard, the processor inside. But a body without a brain telling it what to do is, well, it's just an object, right? Software is that brain. It's the collection of instructions that gives all that hardware a purpose and really brings it to life.
So if we want to get a little more formal about it, software is basically any set of instructions that a computer can read. Its one and only job is to tell the computer's processor what to do, what specific operations to perform. It's the language that translates what we want into actions the machine can actually execute.
But here's the thing. Not all software is created equal. It's really helpful to split it into two main categories that work together in this kind of beautiful partnership. You've got application software and system software. One is the stuff you see and interact with, and the other is working tirelessly behind the scenes. And this separation is absolutely key. Application software. That's all the programs we choose to use every day. Think Microsoft Word for writing a doc, a web browser to surf the internet, or a game to just unwind. But, and this is a big but, none of that would even be possible without the system software. That's the foundation everything else is built on, like Windows or Mac OS. You don't really use it in the same way, but it's what's running the whole show.
And the most important piece of system software, the true star of the show, is the operating system. I like to think of it as the conductor of a super complex orchestra. It's making sure every single section, the hardware, the applications, and you, the user, all play together in perfect harmony.
So yeah, the crucial point here is that the operating system, or OS, is the master manager. It is the central hub that just stands in the middle of everything. It takes requests from your applications, translates them for the hardware, and makes sure all the resources are shared fairly and efficiently. It's what keeps the whole system from descending into chaos.
So the OS is constantly juggling three huge jobs. First up, processor management. It decides which of your open programs gets to use the computer's brain, the CPU, at any given millisecond. Second, memory management. It carves out and allocates chunks of RAM to each app so they have the workspace they need to run. And third, file management. It organizes all your stuff, your documents, photos, programs, on the hard drive so you can actually find them later.
Okay, so we know the OS is the manager, but how does a simple command, like you typing a letter in a document, actually become an electrical signal? For that, we've got to peel back the layers and follow the journey of one single instruction, all the way from a human thought down to a machine action.
This journey has 4 key steps, and each one is basically a translation getting closer and closer to the machine's native tongue. It starts at a high level with a language like Java or C that's pretty easy for humans to read and write. That code then gets translated into a lower-level assembly language. From there, it's translated again into machine language, and that's the pure binary code, the ones and zeros that the processor can actually understand. Finally, you get to the digital logic level, where physical circuits and gates are literally opening and closing, representing those ones and zeros with actual electrical pulses.
Which, of course, brings us to the final step. We've got the ones and zeros, we know their instructions, but how does the physical hardware, the CPU, actually read them and execute them? Well, it happens through an incredibly fast, endlessly repeating cycle.
This right here is the heartbeat of your computer, the fetch, decode, execute cycle. It's simple, but it's powerful. First, the CPU's control unit fetches the next instruction from memory. Then it decodes that instruction to figure out what operation it's supposed to do. And finally, the arithmetic logic unit, or ALU, executes the command. It does the math, moves the data, whatever it needs to do. This 3-step dance happens billions of times, every single second. It's mind-boggling.
But today the story of software doesn't just happen inside your computer anymore. More and more, the software we use and the data we create exists somewhere else entirely, in what we all call the cloud.
So what even is the cloud? It's not some abstract mist up in the sky. It's actually really simple. You're just buying computing services from someone else's data center and connecting to it over the internet.
Instead of running on your machine, the software and hardware are running on these massive servers owned by companies like Amazon, Google, or Microsoft. Now, this whole model of delivering services isn't a one-size-fits-all kind of deal. It's usually broken down into 3 main categories, or flavors, and each one offers a different level of control and management. We call them the as-a-service models.
First up, and this is the one you're probably most familiar with, is Software as a Service, or SaaS. This is where you just use a finished application over the internet. Think about Netflix, Gmail, or Dropbox. You don't manage the servers, you don't manage the operating system, you don't manage anything behind the scenes. You just log in and use the product. Simple as that.
The next level down is Platform as a Service, or PaaS. This one's really for the developers. Think of it like a complete workshop. It provides the servers, the operating systems, the databases, all the tools they need so they can just focus on building and running their own apps without worrying about all the underlying infrastructure.
And at the most fundamental layer, you've got Infrastructure as a Service, or IaaS. This is like renting an empty digital warehouse. You get the raw computing resources, the servers, the storage, the networking, and then you are responsible for everything else, from installing the operating system all the way up. It gives you the most control and flexibility, but also the most responsibility.
So why is this whole thing so revolutionary? Why is everyone obsessed with the cloud? Well, it all comes down to one word: elasticity. With the cloud, you can scale your computing resources up or down almost instantly. If your website suddenly gets a huge spike in traffic, you can handle it. Then you can scale right back down when it's over. You only pay for what you use. And that's what makes powerful computing accessible to everyone, not just the giant corporations.
And this all brings us to a final and kind of provocative thought. As our digital lives, our software, our documents, our photos, our memories, as all of that moves from our own hard drives into these massive centralized data centers, what does that really mean? In essence, are we all just borrowing time on someone else's computer? And what does that shift imply for the future of data ownership, privacy, and control? It's definitely something to think about. Thanks for tuning in.